Okay, let's get started. So, kudos to you for waking up super early on this cold Friday morning. I'm glad you're here. So, I have two announcements. Well, three actually. What starts next week? Labs. So, make sure to go to those. We finally got the TA and lab situation straightened out. So figure out which lab section you're in, and here's the handy table for who should be present at your lab section. From what I can recall, although I can't verify this for sure, I believe the labs have all Windows computers, which is an issue if you want to be using the test cases and all of that stuff. They don't have the compiler, the C++ compiler natively installed. Either you have to install it every time, which could be a hassle, or you can bring your own laptop. You don't have to use the computers there if you don't want to. Or if you just want to build and run your programs, you can go to this website I put right here, and then if you go here, then you can just enter your program, click run, and you're off to the races. So then you can actually here in the standard input part, you can actually put one test case at a time and then see what actually happens. You can't do it all at once, unfortunately. So what I would recommend is either try to figure out how to integrate it with the existing laptops there, or use cpp.sh, or if you have a laptop, use your laptop with the build system installed on it. And then the other announcement I had was assignment 1's going to be posted sometime early next week. And the main purpose of it is to step up a little higher than Lab 1 to still get you familiar with how to use the build system, the environment that you're setting up. But there's not going to be a code skeleton provided to you. So you're going to have to write the actual program yourself. Okay? But it's actually it's a cool short assignment, and I hope you like it. Any questions before we start? Or any questions about last lecture? Yeah.
I didn't understand the last thing that we did.
Okay. So the last thing that we did, do you mean the high level to executable part?
Yeah, when you was like typing.
Oh, so you mean when I was like running the program, you mean, like this?
Yeah.
Okay, so what are the parts of converting a high level to an executable file? So the source code is what we're going to be writing. So we're going to be writing the source code in a file. No, I do not. So we write all the source code in some file. Let's call it hello.cpp, although the name doesn't really matter. We run it through this thing called a preprocessor. We don't know what that is yet. But basically what happens is that it gathers all the necessary code from the C++ library and maybe other libraries and literally copies and pastes it into our program. So if it needs some other code, it brings it into our program so everything will work fine. Then from that, we get the modified source code, which is what we wrote, plus copied and pasted any libraries that we were going to use. Then the compiler is going to look at this modified source code and say, I'm going to try to convert this to something that the machine can recognize, that can actually execute. So it looks at our high-level pieces of code and then converts it. Its job is to convert it to a form that the machine basically can understand. So that's what is called an object file. Then a final step, when we want to run, we have to run something called a linker. We won't worry about what this actually does, but it links it to any other libraries that couldn't have been brought in the first step with the preprocessor. And then from that, we get some executable code that we just say, I'm going to run it, and then the machine runs it. So what actually happens when I gave the example last time? So if we look at this example, so this is the example I had from before. So what do I run to run the preprocessor or the compiler or the linker here? G++. The compiler So there are many compilers for C++. One of them that is very popular is the GCC compiler, and it's named G++. That's the name of the compiler. But what's interesting about G++, or really any compiler that you're going to use, is it packages all three into one. It does the pre-processing step, the compilation step, and then the link step all in one go, so that we don't have to do anything else, which is nice. So if I just run G++ on the file that is over here, then we're going to, if I do an ls, we see that an a.out file was created. So how do I run this a.out file? The dot slash and then a.out. So then if I do dot slash a.out, and then it prints the, it does cout hello world. It prints hello world. Okay? Does that answer your question on how it actually works? So we'll worry about the actual details of what actually is happening later, but just at a high level, does that make sense? Yeah.
So actually, I have a question about this. So in the previous slide where it goes on how to run high level program, you said source file directives gets converted to source code statement.
Yeah.
I get what happens after that and how it gets
converted
to machine code. But what's the difference between file directives and program statements?
Great question. So the question is, what is this thing called a file directive? And what is the source code program statements? The answer is, let's go back to this. Anything with angle brackets like this, so we'll get to this, but just as a preview, anything with angle brackets like this with a hashtag include, that is a directive. And then everything after that, that is a program statement. So the directive means that there's some code in this IO stream, whatever it is, and so it's going to copy the code from there to our program. We don't see it happen, but that's what it actually does. Yeah?
Would you prefer us to run G++ on terminal only, or would you be open to us using something like code blocks also?
Yeah, you can use any environment that you wish. The only issue is that if you want to make sure that your program's working with respect to the test cases, I'm not sure if you can integrate it with your code blocks or any other development environment that you have. But you're free to use any environment that you wish to develop your program. And then maybe as a final step, what you can do is just see, does it actually pass the test cases? And then maybe make small adjustments as necessary. But you can use any environment that you wish. In fact, you can ignore the test cases if you want, but that's probably not a good idea. Any other questions? Okay, so this is what we covered last time. So we started here. So what does a program consist of? And then the things that we saw were keywords, things that are unique to the language, that have a defined meaning in the language. Some identifiers that we are going to make up ourselves, some operators to manipulate data, punctuation, and syntax. So this is just an example of a program. We looked at this last time, and we reasoned that just by looking at it, there's something to do with 5, 12, and looks like addition here. So it seems like the sum is 17 is going to be printed. Did anyone run this to see if I'm fooling you or anything? So what is my advice to you after class? Run this, make sure it actually works, okay? So the number one thing that we'll be seeing is that a statement that is written on the slides, so these slides are mainly from the publisher, not from me. Statements from the publisher may seem like a good statement, it's true in general, but what is one way that you can actually verify whether a statement written on here is actually true? Write a program and run it, right? So there's a really easy way to verify what the publisher actually says. And actually, sometimes it's just not true. And we'll see that throughout the class. So just be careful when you read something online about C++ has this feature and it works always in this case. That's not necessarily true. So keywords we looked at last time. These are, another term for this is reserved word. Keyword, reserved word, those are the same thing. They have a defined meaning in C++, cannot be used for anything else, and usually written in lowercase letters. And so we saw some examples of this. You don't have to know what these mean yet. We will get to what these actually mean, but just know that there are some words that have a unique meaning in C++ and cannot be used for anything else. And notice the things over here, these are not keywords. So they don't have a defined meaning in the language. Whereas the using namespace and the int thing, those have a defined meaning. But if we want to actually do something useful, we want to actually write something ourselves and manipulate data ourselves. And the way that we do that is we create these things called identifiers. Another word for this is variable, but identifier is a good term for it. So what are identifiers? They're just names that you make up, not part of the language. And the main purpose of them is to hold data. So if you remember back to that example with the 5 and the 12 in it, the num1 variable or identifier holds the value 5, and num2 holds, I think it's num2, holds the value 12. So these identifiers are just a placeholder for holding data, okay? So if I want to store the number 5 in an identifier, I create an identifier, and I store the number 5 or whatever value I want in there. And then if I want to manipulate the data, I don't manipulate 5 anymore. I manipulate the identifier that I just created. So if we go back, notice here I'm manipulating with num1 and num2, not the values 5 and 12, right? So by doing this, I can change values of these identifiers throughout the course of the program. So maybe, for example, if you want to compute the 100th Fibonacci number, then what you can do is do something like this, where you create an identifier for one Fibonacci number, then the next one, and then the next Fibonacci number is the sum of the previous two. And by doing this, all I need to work with are the identifiers that I create. I don't need to know the exact values along the way, which is pretty cool. So basically, identifiers hold a value. That's their purpose. So the num1 here is an identifier. Okay, so this is an identifier that we create. Do I have to call it num1?
No.
Could I call it Ryan in Arizona if I wanted to? Yeah. No. Yeah, I can call it pretty much anything I want, and we'll go over things that are allowed in identifier names, things that are not allowed in identifier names. But just note that this is an example of an identifier. It holds a value. But if I want to do something actually useful, instead of just storing a value into an identifier, so what? We want to be able to manipulate the data at our will. And so operators are the way that we can manipulate data through multiple identifiers, or maybe just one. So there are many types of operators. The ones that are most common are plus, minus, times, divide. So pretty much any arithmetic operation you want to do, that is an operation on the identifiers that we create. So remember, we had the num1 plus num2 from before. The plus is the operator. It's operating on the identifiers. And so by doing this, I can manipulate data as necessary. So assignment is actually an example of an identifier too. So this is one thing that we'll touch back on pretty soon. Actually, the example's already in here, never mind. So the example from the program before is, we saw that num2 was, this statement num2 equals 12. This does not mean check equality with 12. So for whatever reason, programmers decided a single equals means assignment. Okay? This may be the most important thing throughout this entire class. One of the two most important things. Understanding that this means assignment. So what actually happens? So this is exactly what happens. The thing on the right is copied into the thing on the left. Okay? In this case, the value 12 is copied into the identifier num2. Okay? Would an error occur if I instead said 12 equals num? Let's see. I'm trying to copy the value, whatever it is, in num into the value 12. Is 12 an identifier? No. So that actually would cause an error, yeah.
If we define 12 as a string thing, can we say string? I don't know why I said
So-
but define 12 as a string.
So we haven't talked about strings yet. So you mean something like this. Because this is not an identifier either. This is actually a different meaning, but it's still a value type, and so I can't assign to it. But it's a good question. So the vast majority of the time, the thing on the left is an identifier because you're storing it into a place that holds a value, right? You're not trying to store something into the actual value itself. You're trying to store it into an identifier which holds a value, okay? So, but could I instead say num1 equals num2? So where both of these are identifiers. Yeah, because I could still have an identifier or anything I want on the right side. I'm not storing into the right side. I'm storing into the left side. So as long as the left side, pretty much, is an identifier, we're all set. No matter what the right side actually is. Okay, does that actually make sense? It's actually really important, but it seems really simple, but it's really important. Okay, so yeah, so that's an example of an operator too. In fact, when we did the cout statement with the double less than symbol, that is an operator too. And there are gazillions of operators in C++. And one of the advantages of C++ is that we can redefine what plus means. So I can have plus mean add the two values and then add 100 after it, no matter what the values are. I can redefine the operators to mean exactly what I want them to mean, which is one of the advantages of C++. And we'll see that pretty much at the very end of the class, why that's important. But another part of programs is punctuation. So recall the example that we had before, where we had this program where we had 3 identifiers here before this semicolon, whatever that does. So we had a num1, and it had something to do with 5. So it's assigned the value 5 from what we just learned. And then we had commas in between. So the commas are to denote where one identifier starts and ends, and then when the next one begins. So num1 equals 5, that's the end of the identifier num1. And then comma, then the next thing better be an identifier also. Comma, then identifier, and then it appears that the semicolon ends this list of identifiers, whatever that actually does. Okay, so punctuation mainly is just to either mark the end of a statement or separate items in the list. So the semicolon here is an example, another example of punctuation, and we'll get to what the semicolon actually does. So just note that there's punctuation in C++. Okay, so you may wonder, okay, well, what does this semicolon actually do? What is that purpose? So let's talk about something called a line in a statement. So let's just say we have a source file of code, and then a line is a literal line in the file. Okay, so it has nothing to do with C++ or anything else. It's just a line of text, and then when the when it's the very end of that line, it's the end of that line. So if you read a file from left to right, and then when you push the enter key, that starts a new line. So that is not relevant to C++. It can be used for any file. Okay? So, but there's a distinction between what a line is and what a statement is. So what is a statement? Oh, okay. So here's an example. So let's just say we have all of this on one line. Then this line 2 right here is on one line. Anything on line 3? No. So this is blank. So you can actually have blank lines in a program. And then here's the 4th line. So then you may wonder, okay, lines are simple. It's just literally the lines in the file. What is a statement? So a statement is one, pretty much, instruction of the computer, of the program that the computer has to perform. So what is an example? So the best way to think of this is just to look at an example. So this is not true in the general case, and we'll see this later. But for now, a single statement is everything until the semicolon. Okay? So all of this right here, how many lines are right here? 2. How many statements are there? 1. Okay? So think of a statement as everything until the semicolon, and then right after the semicolon starts the next statement. Okay? Can I have 2 statements on one line?
Yes.
Yeah, because I don't have to push the enter key. As long as I have a semicolon separating them, I have 2 statements and we're all set. Okay? It could be on one line or multiple lines, and in this case it happens to have multiple lines. So why do I say this is not true in general? Some statements that we're going to see don't even have a semicolon at all. So it's good to think of it that way now to get the vocab in motion, but we're going to talk about different types of statements later on. But think of it just as everything until a semicolon. Any question on lines versus statements? Yeah.
Just on this little bit in particular,
Mm-hmm.
this piece of code over here wouldn't work, would it? Because
Mm-hmm.
you haven't assigned a value to num2 yet.
Great question. So I'm not assigning a value to num2, right? So could the C++ people say, that's not allowed? You have to initialize a value every single time. Could they have said that?
No.
They couldn't? They're defining the language. So could they say that every identifier, when it's declared, whatever that means, does it have to be initialized? They could have said that, but here you can have uninitialized data. And there are very, 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 and I mean this by like last month, pretty much, parts of C++ which force you to have an initialized value. But here, we don't have to have it. And we'll talk about that sort of thing, when you have to have an initialized value, when you don't. But here you don't. Any other questions? Actually, this is a really good segue. Well, not a segue. Let's look at this. So let's look at this example. So let's just copy this in. And let's just print out num2. And then maybe an endl to make it easier to read. Anyone have an idea what's going to be printed? So who has a guess? Well, it's printing something. It's printing a value. It might print 0, yeah.
The address location?
We're not to addresses, but this won't print the address because I don't have the address operator there. We'll talk about that, though, later. So it prints 0. Let's try int. 0. So the really strange thing here is that we can't guarantee the value of an identifier like this if it's not initialized to something. So sometimes what might happen is this value is just some random value because I didn't initialize it. And there's a whole reason why that's the case. So my advice is always initialize your data unless you absolutely know what you're doing. Okay? So always initialize your identifiers. So what I would do here is I would set everything to be 0 unless it needs some other value. Okay, so those are lines and statements. So variables or identifiers, remember they're the same thing. So a variable like num1 or num2 or whatever, they're just a named location in memory. So remember, we had this random access memory, which is where our program's actually running. A variable is just some piece of that memory. So when we declared this variable over here, this num1, num2, whatever, those are going to occupy some slot in memory. Okay, so the 5 is going to be stored in one piece of memory, 0 is going to be stored in another piece, 0 in another piece of memory. Yeah, so it holds a piece of data. And of course, the data it holds may change while the program's running. Because remember the earlier example, when we set sum to be equal to num1 plus num2, we're modifying the sum variable, which had a default value of something, to be 17. We're modifying the original data. And as you might expect, the name of the variable should reflect its purpose. But let me ask you this. Does the compiler care what the name of the variable is? No. What the actual name of the variable is? The compiler doesn't care. It just sees a name of the variable. Are computers smart or dumb? Dumb. No. So they don't know what an English language is. All they see are just characters. So they just see an identifier, some name. It doesn't care what the actual name is. As long as you use the same name everywhere, the compiler won't care. So the real purpose of a variable name is for you and anyone reading your code. So remember, we're writing in a high-level language. We want to be able to read the program. The compiler doesn't care. It just sees a whole bunch of data. It doesn't care what the name or the organization of your program actually is. Remember, it's for you and anyone reading your program. A variable must be defined before it can be used. So if I have, if I swap the order of these two statements, then the compiler is going to actually complain to me. Because, so here's actually our first error. It says use of undeclared identifier num2. So it's going from top to bottom, and it sees, oh, you're going to reference this thing called num2, whatever it is, but I haven't seen it declared yet. I'm going to throw an error and assume that you did something wrong. Okay? So always declare a variable before it's actually used. So we're going to talk about this in a few slides, but C++ is a language which works mainly from top to bottom. It works from top going down. So what I like to do usually is to declare all of my variables, identifiers, right at the very top, and so I won't have this issue. So if I need some variable or identifier way down below, it's already defined at the top, so there's no issue there. Okay. So it must be defined before it can be used. Yeah, the definitions indicate the variable name and the type of data. We will talk about the types of data that variables can have. So one variable may hold a certain type of data, another variable may hold a different type of data. We'll talk about that later. So here's a variable definition. So what happens here is we'll talk about what double actually means, but the type of the variable must occur first. So double is the type, whatever that is, of this variable. And then right after it is the identifier name, the variable name of right here. So num1 is the name of the variable and doubles the type. Okay, so those are the 5 main types of things that we'll see in programs. So what about actually running the program? So the 3 main steps are getting input from the user or from a file or whatever, process it, output it. Okay, so nothing really surprising here, and I think we covered this. So just remember, you're trying to get input in some way, you're going to process the data in some way, and then output it in some way. So an example of this may be, suppose we have a parabola, okay? So like ax squared plus bx plus c, and maybe we want to know what the roots of that equation are. So then I won't make you recite the quadratic formula, but what could be an input from a user? Yeah, A, B, and C. So the quadratic formula needs the values A, B, and C. So then that would be the input from the user. What would be processing the data in that case? Right, yeah. So just taking the values that are inputted by the user and then throwing them into the quadratic formula, and then saving the result of that computation to a variable. What would be outputting the results in this case? So how many roots of a quadratic equation are there usually? 2, right? So then what we would have to do is print one root of the equation and then print another root of the other root of the equation. Yeah, go ahead.
We also have it output to show a graph of the.
Possibly, yeah. So that might be another thing that we would need to think about. What types of things do we want to output? Are we just outputting the roots? Are we outputting the intercept at the y-axis? It depends on what we're trying to actually do. So a perfectly good example would be output a plot of the graph. That would be a perfectly valid thing to do. So thinking about what input you need, how you're going to process that input, and what things you want to actually output for the user are really important. So if you don't want to inundate the user in any way by having them put in a whole bunch of input or showing them a whole bunch of output. You want to only produce what is necessary for them to effectively use whatever system that you actually just made. Okay, so I know there are a lot of steps here. So this is just one way of approaching programming. I'm not going to have you memorize this, and I'm not going to test you on it. But it's a good idea to think about. So the main steps are just basically try to understand what in the world you're doing, right? Figure out what you actually need to accomplish. But one of the important steps to internalize here is don't immediately start programming. So I make this mistake actually fairly recently. So I went ahead and tried to implement something in my research, and it just fell on the floor. It just didn't work. I needed to think a little harder about how to actually implement it first before I even write a single character of code. Okay? So just try to visualize how it works. And then maybe think, what is the overall idea here? What is the input that I'm going to expect from the user? Am I going to possibly have some error input from the user? Maybe they put in a bogus input. You need to think about that sort of thing. How am I going to actually process that input? And then try to break that down into subtasks. So if I need to accomplish this overall goal, if I do this little thing, this little thing, this little thing, and this little thing, put them together, I'm all done. So then all I need to think about are those 4 steps, and then think about each one in turn. So that compartmentalizes my thinking to make it easier for me. And then once you have this model of how you're going to approach it all set, now you actually start programming, then compiling, testing, and then trying to fix things that went wrong, maybe add a feature that sort of thing, and then just repeat until you're done and you retire. Okay? So that's basically how you should approach programming. But you shouldn't take from this that this is an individual thing. This is not, I'm not mandating this to you as the way of approaching a problem-solving thing. You need to think about what is right for you and how you should approach it. People approach problems in programming in different ways. But this is a general way that you can start doing that. But remember when I said that C++ is a top-down language where we worked from the top down? That's actually what is called a procedural program. So a procedural program in general is, as you might expect, a process-driven program. So the main purpose here is you're processing data. So you input the data at the top, you process it in the middle, you output it at the end. So that's the main 3 steps along the way. But C++ has a dual side to it. It's not just top-down, but you may have heard this term called object-oriented. Who has heard object-oriented before? Okay, quite a few. So this is a little bit different, and we'll get to this in the second half of the class. But the purpose here is, instead of having all these variables that have this data, so like each variable has one piece of data, another variable has another piece of data, what if we just packaged a whole bunch of data all in one place? And then what we do is we only view all of this data in one thing as a single entity. Wouldn't that be a lot easier to work with? So that's what's called object-oriented programming. We view things as what are called objects to make our life easier. But we'll talk all about that in the second half. Just note that C++ is both a procedural and an object-oriented language. And depending on the application that you're going to be writing, procedural might be better, object-oriented might be better. So the first half of the class is mainly about procedural programming, writing some procedural programs. And then the second half will incorporate some object-oriented programming into the procedural programming, combine them together to make some really cool programs. Okay, yeah, we'll focus on both of these. Any questions on the first set of slides? Yeah.
So that num1 plus num2 equals sum, will that be procedural or object?
That would be procedural. Yeah. So because I didn't declare something called an object here, and so therefore it's not an object-oriented thing. So don't worry about what object-oriented actually looks like. We're going to get to it eventually. Just think top-down for now. But just note that C++ has 2 sides to it. You had a question? Someone had a question?
Procedure, you mean like from top?
Yeah. So procedural, you can think of as top-down. So we go from the top of whatever we're looking at to the bottom of whatever we're looking at. And whatever we're looking at, we're going to get to in the next set of slides. And pretty much the rest of the class. Any other questions, though? Okay, let's start the next set. So that's just an introduction to C++ and programming in general. Let's actually talk about the language itself. So hopefully I've tried to motivate programming in a general sense, but let's actually dive into what the C++ language actually is. So let's just look at the simplest C++ program, which is what is called a hello world program. So here we have a lot going on, and we'll get to all of this in nitty-gritty detail. So the first line is something called a comment. We'll get to that. I mentioned this before, but we'll get to it later. Something called a preprocessor directive, which is the hashtag include thing with something in between angle brackets. My least favorite line in all of C++, this one, I'm not even going to bother saying it out loud. And this comment from the publisher, this is not my comment, this is kind of misleading, and we'll get to why that is. But But it's okay to use this for this class. I won't be very offended. But just note that don't use that line if you're going to go out and actually program in the real world C++. And we'll get to why this is a bad line. Okay, so this is something called a function, and it's called main. You may have noticed that there's a type right here called int, whatever int means. We have curly brackets in here, whatever they mean. But we kind of have deduced already cout means output to the screen. I hope we have internalized that by now. So that outputs that. Another misleading line from the publisher, whatever this means, sends 0 back to operating system, whatever that means. I know what it means, but we don't know what it means yet. And then the closed curly brace is the end of the main function, whatever that means. So there's a lot going on here in this very short program. This is not a long program, but there's a lot to unpack here. So let's start unpacking things. Okay, so we have things that are called special characters in C++. You may have noticed that the comment right here had these double slashes on the front. That's to indicate something called a comment. We'll get to comments later. The pound sign, I just say hashtag, begins the preprocessor directive. So anything with a pound sign or hashtag, that is a preprocessor directive. It doesn't have to be hashtag include, but anything with a hashtag is a preprocessor directive. The angle brackets corresponding to that means something related to a directive. Open close parentheses used when naming a function, although this is not always the case, but they are certainly used here. The open close curly brackets are to denote the the start and end of a block of code. So if you look at this example, we had the open curly brace here, close curly brace here, and we got some code in between. So the open curly brace, close curly brace means some code's going to go inside of here in this one block of code. The double quotes here is something called a string of characters. We'll get to what a string of characters is. And then we kind of have already learned this. The semicolon means the end of a statement. So the end of the cout statement is the semicolon here. The return 0, the end of that is right here. So nothing too surprising here. So just some important details. C++ is case sensitive. So for example, the main function has to be lowercase m, lowercase a, lowercase I, lowercase n. It can't be anything else. If you use an identifier like num1 somewhere and you want to use it at some other place, it has to be literally the same. It can't have different cases on it. It's case sensitive. If you have an open curly brace, you have to have a closed curly brace as well. And the same thing's true for parentheses and square brackets. We haven't talked about those yet. But just note that if you have an open curly brace or anything that's really opening here, you have to have the corresponding close somewhere in the program. It may be way later, it may be right there. It depends on what the thing we're actually working with is. So let's just talk a brief bit about cout. So we have already deduced this pretty much. It displays information. So the double less than, what is that? What is the double less than an example of? An operator, right. So it's just a type of operator. And cout redefined this operator, so here's an example of this, to mean take whatever is on the right side of that, send it to cout, which means print it to the screen. So if we do this simple command, cout hello there, it prints it out. But the cool thing is that you can actually chain these together if you want. So you don't have to say cout something, cout something, cout something. What you can do is cout first thing, and then another double less than, and then something else you want to print. So you can chain these together if you want.
So are these angle brackets always used with cout, or can they be used with another operator?
So we typically use them for cout, but as we get to the very end of the class, we could redefine this to mean something else. But pretty much the entire class, this is only used with cout.
Before you redefine it, it's going to be.
Yeah, right. So pretty much we're always using it with cout. Yeah, but you can, if you want, if you're insane, you can do cout something and then another statement cout something, if you wanted to. But I typically use this former one because it's a lot easier to work with. If you want to print things on multiple lines, well, we can use endl, or we can use \n inside the quotation marks. So these, for our purposes, do the same thing. But just note, don't use endl in practice unless you know exactly what you're doing, because endl actually does something else. And I invite you to look up what actually endl does. It's actually pretty interesting. So for this class, both of them are completely fine, but just note that there's actually a difference between the two. So let's do an example of this. How many of you have seen the pizza episode of SpongeBob? Okay, well, what is that famous line? I know what it is, but can you say what the famous line from it is? The Krusty Krab pizza? For you. Right? So what if we wanted to make a poster of that saying and then maybe frame it up on the blank wall right there for all to see, right? So this wall is kind of square in nature, right? If I wanted to print the entire thing on one line, would I be allowed to have a lot of text on there? If I just printed everything on one line? No, I can't make the text really big. So what do you think is the solution to that? Print things on new lines. So maybe we can break this up into multiple lines. So then let's just see. Let's just see out the first part of it. The Krusty Krab pizza. And then what do I do to print the is the pizza part on the next line? /n. Could I use endl if I wanted to? Yeah, but I'm going to do \n. Notice it's purple. We'll get to why that is later. Is the pizza. And then what if I wanted the for you and me part on the third line? Another \n. So then if we compile and run, is the, oh, I didn't type it. For you and me. And then I'm going to put a \n at the very end so it's more readable. And so now we printed the three things on 3 lines. Pretty cool. What if I wanted to say, I want to make this look like an actual quote. Instead of having everything aligned on the left, I want the second line to be indented a little bit, and then the third line to be doubly indented. So the \n is an example of what is called an escape sequence. So that creates a new line. What if I wanted the second line to be tabbed in once? Or in the third line tabbed twice? A \t. So let's do an example of that. So the is the pizza one, how many times do I want to indent is the pizza? Once. So I tabbed that once. So in addition to \n, I \t. And then for you and me, how many times do I want to, 2 of them. So I put 2 \t's. So then if I want to run this, it now looks like an actual quote. Pretty cool. What about this? What if I want to actually print it in quotes? So I want to have like a double quote at the beginning and then a double quote at the very end. Could I just put double quote right there? No, because that would say, oh, this is the very end of the cout, what is being printed. What do I do instead? Double quote. So then the beginning is right here. So then I do \quote. And then the very end's over here. I do \quote again. So then if we compile and run, it now looks like an actual quote. What if I wanted to say that this quote was obviously said by Michael Scott? And I want to triply indent Michael Scott. what would I put over here?
Slash T.
Yeah, /T/T/T, and then Michael Scott. Because he obviously said this. Oops, didn't put a new line there. So I'm out of time. I'll see you all on Monday.